Hello everyone, welcome to today's webinar Wednesday. It's going to give us a couple seconds whilst we let people come in before we begin with a brand new webinar. Hope you're all doing well, hope you all had a great week so far, and looking forward to talking to you today about quality metrics, but we'll save that for just a couple seconds before we begin. So we already have someone in chat, excellent, so let's see if we get anyone else. Otherwise, I think we can begin. So, as always, welcome to Go Bigger's webinar Wednesday. Today's webinar topic is defining quality metrics matter. I'll be your webinar host. My name is Benjamin Taylor. Of course, I work with Go Bigger, and I work for Go Bigger. And we're really going to look today at what quality metrics are in testing, why do they matter in general, and how can we make sure that we use the best quality metrics in our testing. Or, to put it simply, what are we doing in this webinar? We're looking at quality metrics in general, giving a general definition, as well as looking over what some commonly used quality metrics are. Plus, then we're going to look at how quality metrics are normally used incorrectly, or some common pitfalls that we can look at and see when quality metrics are used. And finally, we'll end the webinar off with looking at some more, let's say, useful quality metrics. Quality metrics, I think, help tell a better story of our testing progress. So I hope you're ready, hope you're excited for this week's webinar, and let's get started. First things first, so let's look at what quality metrics are. What are they? Well, software quality or QA metrics, we call them quantifiable measures that evaluate a couple pieces of criteria about our project. Not just our product, but our project overall. The first measure that they evaluate is, of course, quality. How correct is it in terms of requirements, in terms of user stories? That's sort of our first search, how sort of correct they are in general. Then we have efficiency. So not only do we want to ensure that our processes are correct and have that correctness to them, but they also should be efficient, and our testing should be efficient in some means. Following efficiency, we also have effectiveness. So not only how effective is our testing, but also how effective is our development. Are we finding these bugs and defects throughout our project, or is it being found by our client, which of course is the not ideal situation? And the importance of quality and QA metrics is that this works, as I said, for both development and testing. So we need to ensure that we're using the right metrics to help tell our story. If we're not using the right metrics, then we're going to have some difficulties in expressing how testing is progressing. This may lead to misunderstanding of testing and testing goals. But why do we use quality metrics in the first place? Well, the obvious answer is because it's quality. It ensures product quality. What do I mean by product quality? I mean both functional as well as non-functional requirements. So product quality is related to both of these aspects. And if we ensure that we're meeting functional and non-functional requirements, then we should have a very high product quality, as long as our requirements are, of course, well defined. We also use quality metrics so we can identify any inefficiencies in our current processes. This could mean that we're identifying areas that could require further attention and optimization, as well as just putting a general focus on process optimization. So if some aspect of a project, be that in development or in testing, is taking longer than expected, then ideally, quality metrics would help us identify that area and how we can resolve it. Quality metrics are also data-driven and enables us to make some data-driven decisions, especially when we're talking with project managers or even people beyond project manager, be that client stakeholders. We really want some data to back up our decisions and our choices. If we say that we need to put a greater focus on testing, for example, then we really need to have the quality metrics to back up that decision. Remember, at the end of the day, projects do cost money. Bringing on new testers costs a lot of money, and thus we really need to make sure that if we go to our project manager or hiring manager and say, hey, we need a new tester on this project, it's too much, we need that data to back it up. And finally, quality metrics can also help us with tracking progress and performance. Not just, of course, the performance of the application, but performance of the project itself. This means we can monitor our project health, as well as overall team productivity and testing effectiveness. So quality metrics are really key indicators that we should use in order to make sure that testing and the project is progressing as expected. And if it isn't, then ideally, quality metrics should help us identify that. So why do we still use quality metrics? Well, there's some other reasons. Well, let's see. Next up, they help us detect issues early. Ideally, if some issues are going to be slowly rising to the surface, then there should be a change in quality in one of our quality metrics that we can detect. This means we can uncover some defects or maybe some bottlenecks that haven't quite been identified yet in our pipeline. Which is great. We also use quality metrics to help us meet compliance standards. This can either be regulatory or industry specific, and so I'm not going to get into too much detail here. But depending on what area you are working in your project, you probably have some standards you have to meet, and quality metrics can assist with that. We also use quality metrics because it not only makes us internally and the team happy, but it can also help us improve customer satisfaction. Of course, if the overall quality of our product is increasing, then it's probably going to make our clients happy. Well, it just makes sense. And finally, quality metrics also enable us to have meaningful collaboration within the project team. And what I mean by this is that good quality metrics will help bring the team together and strengthen the overall communication that we have. So they're very important in that aspect. So that's why we use them. But how do we classify some quality metrics? Well, I'd say ways that we can classify some quality metrics is we can break them up into a couple key groups. First is we have our product metrics. Product metrics is the quality of the software. So all these metrics about quality of software. This can be about how many defects there are currently in the software that haven't yet been resolved. These are how we're progressing, or how much of the software is sort of complete. And those are product measures if they relate specifically to the product itself. Then we have process metrics. Process metrics is probably looking more at the efficiency of QA and development. So how efficient are we being in QA? We may have identified these bugs, but how quickly are we resolving them? How many of them are coming back up after a bug fix has been developed? That kind of thing is more about process metrics. And finally, we have project metrics. Project metrics is sort of the easiest one to understand because it's more about measuring progress and resources used in projects. So we'll talk about some of these quality metrics later on, but internally, right now, let's just keep an idea of these three kinds of quality metrics. So product, process, and project. And let's now look at some commonly used quality metrics that you might have already seen in reporting or otherwise. First up, I want to talk about let's talk about code coverage. Then we'll have a look at requirements coverage, test case pass rates, as well as automation coverage. I'm going to go into these in a little bit of detail and also explain why I think these quality metrics, whilst very common and very useful, do have a couple pitfalls that we maybe should keep an eye out for. First up, let's look at code coverage. So code coverage, as a general definition, is just the percentage of code base or some functionality that has been covered in the tests that we create as testers. We can either break code coverage down into what we call statement coverage or branch coverage, but we can also look at more functionality coverage. This is pretty close to requirements coverage that we'll also cover shortly. Code coverage is pretty useful as it gives us a rundown of how many lines of code essentially, or if we look at statement coverage, for example, how many lines of code we've explored in tests, which is good. 100% statement coverage is normally pretty sufficient, and it will let you know that yep, all the code has been run. Branch coverage looks at conditional statements and branches and says, yes, 100% branch coverage has been met, then all branch exits have been seen, even if those branch exits do not have a statement following. And functionality coverage is sort of the lowest level, where it just says, yes, we are able to perform each of the individual functions that we expect the software to. It's a bit weaker than statement coverage, and statement coverage is weaker than branch coverage. But they're not, we can't quite always have that sort of effect, or always have that rule in place, because code coverage has some problems. First is 100% coverage can be really difficult to achieve. In a small, simple system, sure, 100% code coverage is simple. Branch coverage too, that can be pretty straightforward. But as soon as we start to get to larger projects and larger functions, then that's where 100% coverage can be really difficult to chase. And so you might have some standards and quality metrics in place that say, well, 95% of code needs to be covered in test cases, which is still good. I think 95% is a good number, but it does raise the question, what does coverage actually mean? Because coverage just means that the test case, well, that a test case has run a line. Doesn't mean that it's found a defect. Doesn't mean that it's tested edge cases or tested unknown values. And what I'm trying to say is, just because a statement or branch or functionality has been covered doesn't mean it's been tested. Testing is a process. Testing requires specific data, requires specific information, requires us to purposely look at a piece of code and ensure that it works as we expect. Just because we've run the code once means we may have run a buggy statement or a buggy line of code, but it doesn't mean that the bug has actually triggered. And that's something we should keep in mind when we talk about code coverage. As an example, let's say that we have an addition program, a simple program that takes two numbers, adds them together, and outputs a response. 100% code coverage could simply be that we give two numbers, goes through, outputs a response. Perfect. 100% code coverage, done, dusted. Except, even though we have 100% code coverage, we've never tested the outputs. And maybe, depending on the inputs, we haven't tested fractions or we haven't tested negative numbers. Remember, just because we've covered something doesn't mean it's actually been tested. So what about requirements coverage then? Well, requirements coverage is kind of similar to functionality coverage, where we look at the percentage of requirements that have corresponding test cases. But this still has some similar levels of pitfalls to code coverage in general, in that a single test case can be a coverage of requirements, which for some requirements, they're quite in-depth, they're quite specific, and thus coverage here doesn't mean we're tested. So keep that in mind. Let's say requirements coverage is probably even weaker than functionality coverage in a general sense. Even if we have some requirements that are quite in-depth, we can still be that we're not actually properly testing these requirements. So let's move on to test case pass rate, because test case pass rate is, of course, the obvious one. How many tests have actually passed? how many tests have actually passed in our most recent test run. 100% test pass rate means all the tests have passed. That's perfect, isn't it? Well, maybe not, because test case pass rate doesn't tell us if the tests are of quality. Do they have a high quality to them? Do they just have a search true at the very end of a test case? Do they just pass themselves? Do we properly check? A test case pass rate won't necessarily tell you that, so you need to know what the test cases themselves are. Following that, actually, what are we testing? What are we testing when we look at our test cases? Is the pass rate 100%? Cool. But what is it actually testing? Is it only testing a small subsection of that feature? Or is it testing the whole feature? This is where we can sort of combine test case pass rate and test coverage to get some better ideas, but still keep that in mind. Because we could also be testing different aspects, where if we say, for example, had 90% test case pass rate, then you could say that's pretty good. But if a positive 90% is all in this one functionality, and the other 10% is in a completely different piece of functionality, then that's a bit of a problem that should really be addressed, even if a 90% test case pass rate says everything's going decently well. And lastly, the big issue that I have with test case pass rate is the green check. Because the green check issue is this. Everything looks great. All tests have passed. There is no issue. It means we can relax, right? Well, no, we shouldn't. We shouldn't relax just because everything has a. We should instead make sure that what we've written and the tests that we have are of high quality so that if there was an issue, we'd detect it. And maybe we should refine some tests that will fail and then that should fail even make sure that the system is actually working appropriately. Maybe we need to expand the concept, the range and variety of tests that we're doing. The last quality metric that I want to look at is automation coverage. Now, I'm a big proponent of test automation, of course. So I like this idea. I like looking at automation coverage being the percentage of test cases that we've performed through automation. So not manual tests, maybe pipeline automation, or just general test case automation that we run ourselves. And this is great. It's good to know how much of our test suite is automated. But the important thing is we don't know just from the statistic what is actually automated. We can't know enough about anything to really give us some great stories from it. And remember, as testers, we want to tell stories of our data. We want to tell stories of progress from developers, from bugs, from user stories as well. So just knowing that, oh yeah, we've automated 90% of our test cases, that's like, okay, cool. But questions I have, where is your automation deployed? In what areas? How have you deployed your automation? Because if your automation is flaky, then that could lead to some flaky test cases later on too. So you have to have high quality when you look at your automation coverage as well. And the point I'm really trying to say, looking at these sort of commonly used quality metrics, is that the metrics that we use and coverage overall, they only tell us a small part of the overall story about testing. And the thing with a small part of the story is that, well, we still need a story to go along with it. We still need to tell that story of how we've progressed and what our quality metrics are. Let's look at a small little example for now. In our scenario, you're taken over as a test manager for a small project. Small project's been ongoing for a little while now, and you're just sort of stepping into that role. The current project that you're looking at has a couple of already made features. Let's discuss those. First, we have some tests that were hastily made by developers. This means that the developers don't have a strong focus on testing overall, and thus they didn't put a lot of time into these tests. But it's okay, they reassure you, because they've only built automated tests, which isn't always a case where we don't Well, we don't always want automated tests depending on the service we're looking at. So automated tests can be easy to fake, especially when the tests are written to be passed. The developers will write their code, then they'll write their tests, and they'll change these tests until the tests pass, which maybe that's not the process we actually want. But the developers say, hey, look, we have 100% client coverage. That means we're good, right? We meet all the requirements. We're running automated tests. That means we're all great. Well, in theory, what I see as a tester, I see a little bug hiding just behind that corner. And that's the problem. There are these issues where they've only written automated tests. They've made these tests be passed. They have 100% requirement coverage. Sure, it sounds nice, but there's bugs just waiting to be found, and you know it. And that's what you have to investigate. So, how do we resolve this? How do we bring in some new quality metrics that can resolve this issue? Well, I think the best way that we can resolve this is let's look at building some new tests. And let's look at using some proper test techniques during test creation. Let's not build tests to just pass. Let's build tests using some black box testing techniques, using like boundary value analysis or looking at uh, different pipelines or white box analysis with statement coverage. We use those techniques, we're going to build stronger test cases. We also should try and chase some values, try and build value from the tests themselves. Not just that the tests pass, but build value from the tests so that the tests help ensure the functionality is met. We don't just build these for a green check. We want to make sure that, yes, the software does do what we expect it to do, what we want it to do. And coming back to our ideas of the different kinds of quality metrics, we should also just look at and ensure that testing is impacting the overall project, not just the individual product that we're looking at now, but the overall one. So to assist with this, what we can do is we can have a look at some more useful quality metrics that we have access to. First up, I want to discuss defect leakage, which is how many defects have escaped into production. Of course, if your product isn't in production yet, then defect leakage is a bit hard to measure. But if you're rolling with agile releases at a consistent rate, you'll probably be able to get some defect leakage statistics. Because the less fat bugs were found by users, then it means that we're more efficient at testing. Perhaps our users will find a variety of bugs that we hadn't thought of earlier, that we hadn't figured to test. In that case, that's okay. That's still something we can work on and develop towards. We could also look at a priority index to help us quantify our testing. Priority index, I should say, is sort of asking, well, how pressing are the unresolved defects? We may have several defects open at once that we found, but we may say they're actually a fairly low priority. They don't impact the software all too much. They maybe give some wrong data or information, or maybe it's displayed somewhat incorrectly. But they're not as pressing as a number defect, which may cause the entire application to crash. Sort of having a good idea on the priority of these defects be a great how testing is progressing as well. What are some other quality metrics we can look at? Well, we can also look at a bug reopen rate. So you as a tester have written tests that identified a bug. You sent a bug report to the developer. Developer has come back to you with a fix. It's fixed the bug, great. But then later on, the bug has to be reopened. So how effective are our fixes? If our fixes are quite effective, then great, we can feel quite comfortable in knowing that once we've dealt with a bug or a defect, it's been resolved for good. But if we have these defects opening back up over time, then that's something that we need to investigate in our process. We also have mean time to detection. So say a developer has just finished a brand new feature of the product. So how quickly are defects detected after that component has been created? Now, it can be a bit hard to determine mean time to detection, especially in some large projects, especially if we're looking at areas in which multiple people contribute and bins are added to it over multiple sprints. It can be bit hard to detect, but I'd say it's definitely worth investigating a bit of time into. Because if you can prove that actually this defect, which was really severe, was identified quite quickly after the component had been completed and presented to testers, that's great. That's a great sign. That means that the testers are really looking out, doing their jobs, and finding these defects early, rather than going, oh yeah, that feature we developed like a month and a bit ago, it's actually having some defects now. Maybe it's had these defects the whole time. Who knows? But you've only just noticed it now. That's a sign in which we should really pay attention and look at mean time to detection. It'll tell our testing story. We also have defect density. So defect density is a little hard to sort of explain, say it in general, but it's sort of where and how many defects have been detected in a specific piece of the code. So this can be in a class, this can be in sort of a common functionality or feature, or could be in a whole code base kind of deal. And we just want to identify how common are defects in a specific piece of code. Because if we found one of the uh, fundamentals of testing is that defects like to sort of group together. So if we've found a couple of defects in a piece of code, then we should probably look at that piece of code more, even stronger to investigate to see if there's even more defects that are hiding just below the surface. And lastly, well, maybe not lastly, but as a very crucial quality metrics, the cost of testing. Because as testers, we want to say that we save money. So how much has testing actually saved projects? Which can be hard to quantify. It's hard to quantify just how much testing can actually save. Because it's really easy to say that, well, a development bug is worth much less than a production bug, but we need to specify how that is. If there is a development bug that takes out a server for a couple of hours, well, that's unfortunate. Potentially means developers can't continue working on it. But this is going to be a lot better than if that same bug takes down a production server for a couple of hours and you have clients who need to use it. Of course, that's the most drastic extreme example. Not all bugs will necessarily have a costs associated to them. Costs in the first place need to be worked out using risk management and risk analysis. So not all defects will have a bug necessarily, but if you can get some costs for those defects, then you're really gonna help yourself and help your case by saying, hey, this is how much testing is worth. Probably a good idea if you're looking to bring on a brand new tester for a project where you can say, hey, this is how much escaped defects have cost us versus this is how much we're currently saving. We bring in someone for less than that difference, you're saving money, at least in theory. And those are some of the quality metrics that I really wanted to look at. Because quality metrics are really all about how we communicate testing and we showcase our worth as testers. Quality metrics are how we tell our project managers and our client stakeholders that, hey, we're doing our work. We're making sure that we're doing it well so the project is on track and everything's going to look good. And so we owe it to them and to ourselves that the stats we provide back up what we're doing and how effective we are. Because if we don't provide these useful quality metrics, then maybe they won't fully understand what we're up to and how we're doing it. And the important thing with quality metrics and just software testing in general, found defects are good. We want to find these defects because if we find the defects now, in development or in early stages of production, it means the end users won't find them and they will have a stable experience, which makes them happy, makes your client happy, and should make the whole development team happy. So next time you get a test failed, don't panic, don't worry, because it means you're doing your job as a tester, as a QA correctly. If you get some really good quality metrics, you can spin that story. So that brings us to the end of today's webinar. Of course, if you have a question, feel free to put it in the chat. I'd love to see it, and I'll be happy to answer any that do pop up. But as I wait for any questions that may come, first of all, let me thank you for tuning into today's webinar, and I hope you all enjoy. If you are not already following us on LinkedIn, then why not go ahead and check us out? We keep you up to date with everything that we're up to as Go Bigger. Plus, you can sign up to our next webinar events, as we always put our webinars as a LinkedIn event. Plus, if you want to stay up to date and interested in learning more about software testing from us, then why not go ahead and check out our shop page to see our available courses and workshops. Right now, we're offering a 3-day course on the Robot Framework Certified Professional Certification with a 10% discount if you book 2 or more weeks in advance. So why not go ahead, check that out, and upskill yourself so you can become an even better tester. And lastly, if you are interested in following us, you're already following us on LinkedIn, you want to stay up to date, want to know about things as soon as you can, as well as future webinars, then why not subscribe to our monthly newsletter, Grow Bigger. We email you once a month to keep up to date with what we're doing at Bigger, as well as any relevant software testing news or software testing conferences that we think you might be interested in. So why not follow us up there? It's just one click. You can unsubscribe if you want later on, but we really do appreciate it. As well, of course, liking our LinkedIn page and sharing this webinar and our videos. But I think that covers it for today's webinar of defining quality metrics. I'm happy to answer any questions if you all do have them in the comments below. So if you have any questions or have any comments, I would love to see them. And indeed, I have a question here in the chat. Would I say that you should use quality metrics as a manager? Check which of your colleagues are the least effective. Ooh, that's a good question. I personally don't like the idea of sort of throwing someone under the bus, even if you're not doing it publicly. I think it's sort of good to know generally how different testers and quality assurance engineers are performing in a team. Maybe if someone's not pulling a sort of own weight. It's a really good question. I'd say then yes. I'd say you should. As a test manager, you should be aware of what your QAs and what your testers are up to right now. But what you do with that information is a really important part. We remember, we're all a team. We should be supporting each other, working with each other. So we're not going to use it as an excuse to throw someone under the bus, to say, actually, all the quality problems point to them, it's their fault, unless, of course, maybe you think they're doing it deliberately. But generally, use that knowledge, use that information to pull them aside and go, hey, I've been looking at how you've been performing, and I see that you're having some issues. Then work out sort of a coaching session, work out sort of a mentoring system so you can level them up to everyone else's standards. So yes, I think it can be a good idea. Just be careful with how you use it. And I hope that answers your question. Oh no, what have I done? Well, it happens, sadly. Sometimes some people may not be pulling their weight in a project, and well, now you have the information to back it up. But I think that brings us to the end of today's webinar. So I hope you've all enjoyed. Hope you've all learned a little bit too. We're going to take a break next week and the following week. I'm getting a little busier in my professional life because I do work outside of this webinar. So unfortunately, I'm only going to be doing webinars once a month for a little while. But in a couple of weeks' time, Daniel Syme will be coming back and doing a brand new webinar looking at mocking, stubbing, and spying. Really interesting topic. I'm looking forward to it, and I hope you all are too. Until then, have yourselves a great rest of your week. Thanks for tuning in, and we're looking forward to seeing you in our next webinar. Goodbye.